I am Mr. Talib, and now we will continue our lesson about angle of elevation and depression. We have here a ship sailed from a certain point in direction of 70 degrees east of south at a speed of 12 km per hour, and at the same time another ship sailed from the same point in the direction of 55 degrees north of east at speed of 5 km per hour. Find the distance between the two ships after 2 hours to the nearest 2 decimal. First, we must draw a directions. We have x-axis here and y-axis. This is y-axis and this is x-axis. And this is the certain point O. This point is the point O. So this is a certain point, say point O, and this is a certain point, and this is the east and northwest, and down is south. So we can, and this is south. The first move from 70 degrees east of south. East of south will be here. And the second sailed from the same point in the direction 55 north of east. North of east will be here, like this. In this direction. After 2 hours, the first cut 24 km because its speed is 12 km per hour. After 2 hours, it cut 24 km, so the distance here 24 km to reach point A. Second speed is 5 km per hour. After 2 hours, it will cut 10 km to a certain point, for example B. So to find the distance between A and B, you must know the angle between AO and OB. So the direction of 70 east of south, it will be 70 here, and this angle will be 20, and the second 55 north of east here. So this angle AOB, it will be find distance AB by using cosine rule. So in triangle AOB, AB power 2, we can use cosine rule. AP power 2 equal 10 power 2 plus 24 power 2 minus 2 times 10 times 24 times cosine 75. The answer will be I will calculate it. 10 power 2 plus 24 power 2 minus 2 times 10 times 24 times cosine 75. The answer will be 552. Approximation square root approximation 24.23 to decimal approximation 20.49. Another one. A pilot observed two observatory stations A and B on a horizontal land where AB is meter to find the measurement of their two angles of depression theta and alpha respectively. If the plane and the two observatory stations are at the same vertical level, the height of the plane on that time above the ground equals h meter and the vertical projection of the plane belonging to AB. Prove that h equals s over cotan theta and cotan alpha. So we have here a pilot and observe two observatory stations on the ground. This will be the ground. This is the ground. And from here, from the pilot, we can draw a horizontal line. To draw the depression angle. The first angle from here to here is alpha, and the second is theta. So 1A, this is A and this is B, and the distance between A and B is S meter, and two angles theta with A and alpha with B. So this angle alternative is theta and this is alpha. So you can find the height h of the plane to the ground like this. This is the height h. So to prove that h equal cotan theta plus cotan alpha, I can use the two triangle, this point for example D, and this point for example C, in two triangle ACD and CBD. In triangle, first ADC we have cotan theta equal adjacent AD over H. So the length of AD equal H cotan theta. This is number one. The second triangle, in triangle CDB cotan alpha adjacent DB over opposite H. So cotan alpha, so DB equal H cotan alpha. This is number two. By adding 1 and 2, this is equation number 2. By adding 1 and 2, by adding 1 and 2, we have AD plus DB, which equals to S, equal H cotan theta plus H cotan alpha. We can take H common factor, so it will be cotan theta plus cotan alpha, and this is S, so H equal S over cotan theta plus cotan alpha. Another one, a ladder of length L is placed by one of its ends on a vertical wall and the other end on a horizontal land. The ladder inclined to the horizontal by an angle of measure alpha. So you have a ladder in a wall and a land. This is the wall like this, and this is the land. And the ladder will be like this. This is so this angle will be alpha, the inclination to the land. This angle will be alpha. Let me continue. And the lower end of the ladder move for a distance S meter far from the wall. This lower end move S meter. So this will be like this. We can move it here. This will move S meter like this, and this will be like this. This move S meter and this move down. So the next step, we can draw again the ladder from this point to this point. after move S meter. And the horizontal ground, this will be S meter. So this will be S meter, and the angle change from alpha to b theta, and the length of the ladder in two cases is L. So the ladder is the red line is L in two cases. So here L and here L, and this angle is 90 in all cases. So we'll call it A, B, C, and D. So, and this is ABC, and the second EDB. To triangle, we need to prove that L equal S cosine theta minus cosine alpha. So, in triangle ABC, we have cosine alpha adjacent BC over hypotenuse is L, BC equal L cosine alpha. This is number one. The second one in triangle DBE cosine theta equal B L. So BD equal L cosine. By subtract 2 from 1, this is equation number 2. By subtract 2 from 1, minus BC L alpha minus L cosine theta. BC equal B equal DC, which is S. The common factor, so it will be cosine alpha minus cosine theta. So L will be S divided cosine alpha minus cosine theta. This one. Thank you very much and see you later.